When we picture the solar system, we usually imagine a quiet, orderly machine, perfectly round planets traveling in continuous circles around a stationary star, or in roughly 1,300 individual Earths before you run out of space. Put another way, if you placed every other planet onto a scale, Jupiter possesses more than twice the mass of them all combined. A planetary body holding that much concentrated mass and kinetic energy exerts extreme forces. It doesn't quietly follow the mechanical rules of the solar system. To understand the reality of our cosmic neighborhood, we have to examine how Jupiter's massive scale physically warps the space around it. Take the rule that says planets always circle a fixed stationary star. Jupiter pulls with so much external gravitational force that it actually forces the Sun to share a pivot point. The center of gravity for these bodies isn't inside our star. It sits in empty space, just outside the Sun's edge. Locked to this center, Jupiter drags the Sun. As the gas giant orbits, it forces our star into a continuous, tiny circle. Jupiter also defies the assumption that planets are rigid, spherical globes. Despite being 11 times wider than Earth, the gas giant whips through a full rotation in under 10 hours. This wireframe model demonstrates the physical reaction to that kind of spin. The material specifically at the planet's equator has to travel at an extreme speed just to keep up, pulling the center outward while forcing the poles to sink inward. Look at this photograph of the planet. That continuous whipping motion means the gas giant isn't a globe at all. It is permanently squashed into a flattened oval. Its sheer mass and kinetic speed overwhelm the structure of the largest objects in space, working our star's orbit and flattening the planet itself. We also assume that major planetary landmarks are solid, permanent physical features on a surface. But examine the actively swirling bands on the outer edge of the Great Red Spot. This famous marking is actually a single monstrous hurricane, producing winds that scream at hundreds of miles per hour. This animated scale model shows the incomprehensible size of that vortex. You can drop the planet Earth entirely inside the hurricane's eye. Astronomers have continuously tracked this specific storm for at least 350 years, but today its outer boundaries are actively shrinking, meaning the solar system's longest-lasting weather event is slowly fading away. Jupiter's gravity also creates unexpected environments far out in deep space, where water lacks a powerful internal heat source and should freeze solid. This photograph shows Europa, one of Jupiter's moons. It orbits the gas giant encased entirely in a miles-thick outer shell of solid ice. As Europa orbits, Jupiter's massive gravitational pull physically grabs and continuously stretches the entire moon body. That relentless mechanical squeezing generates immense internal friction, which melts the ice from the inside out. This friction maintains a hidden global saltwater ocean entirely beneath the ice crust, holding more than twice the liquid water of all Earth's oceans combined. Jupiter's intense gravitational pull accidentally provides both massive amounts of liquid water and steady heat. It powers the solar system's absolute best environment for a future mission to find alien life. Perhaps the most basic rule is that planets and stars are constructed from entirely different materials. But if you break down Jupiter's chemical composition, it is made of mostly hydrogen and helium. It shares the exact same primary elements as the glowing surface of our Sun. This diagram illustrates the basic ignition mechanism of a star. Immense gravity pulls a massive volume of raw gas inward, creating crushing weight at the center. Under extreme pressure, hydrogen atoms are violently forced together. This process, nuclear fusion, bursts with immense energy. But Jupiter faced a strict physical bottleneck. To cross that critical fusion threshold, the planet needed exactly 80 times more mass to provide the necessary crushing weight on its core. Because it lacked that extra mass, it never caught fire. It sits perpetually below the ignition line as a giant ball of gas, glowing faintly with its leftover internal heat. Jupiter is literally a failed star. And because it stopped growing just short of that mass limit, we survive under a one-star sky today.